Okay, so I've set up the AVR here with a 220 volt plug going to terminals 5 and 9. The bridge is connected between 3 and 4, and my 40 watt light bulb is connected between 1 and 2. The reason for the light bulb is to physically load the AVR to check that it can actually handle current going through it. So if I add 220 volts to it, you'll immediately see that the LED starts to flash. Right? If I then turn the AVR voltage trim pot down to 0 and I start turning it up, it will get to a point where the light starts to glow, and if I then turn it back, the light will go out. So this proves to us that our AVR is operating correctly. Okay, so here we have our R120 AVR from Leroy Saumur, and we have our light bulb, our 40 watt light bulb, connected to terminals F1 and F2, which is the excitation circuit, the circuit that goes to your exciter. We have our neutral from our 220 volt supply connected to N1 and jumping to terminal N. We have our 220 volt live connection connected to U on the AVR, and we have our voltage pot turned down to minimum. So if we apply 220 volts, you will see the light bulb gave a quick flash, and if we put our screwdriver on the voltage pot and we slowly turn it up, we will get to a point that our light bulb starts to burn. And another interesting thing we'll see is that the overexcitation LED starts to burn, which would be the case due to the fact that we're now putting over 150 volts, which is enough to light up this incandescent 40 watt light bulb, but which the AVR knows is overexcitation. However, in our case, we're just trying to test it. So if we turn this back down again, our excitation goes away and the light bulb turns off. So this is just to prove to you that this type of test could be done on any AVR. An AVR that requires 110 volt sensing, you would then use 110 volt power supply on the same type of principle.